Please don't forget to click the subscribe button and click the notification bell for the most updated videos. For today's lesson, we are going to discuss all about representation of rational functions. First, let us define what is meant by a rational function. A rational function is a function that is a fraction where both the numerator and denominator are polynomials. That is, a ratio of two polynomials p and q where the denominator is not equal to 0. So we have here f of x equals p of x divided by q of x, where q must not be equal to 0. If in case the denominator is equal to 0, therefore that is not a rational function, and the answer for that is undefined. Identify which of the following a rational function. So we have here number 1, f of x equals x plus 6 divided by x plus 5. This is an example of a rational function. The second one is f of x equals square root of x divided by x plus 3. On the second example, this is not an example of a rational function. Why? Because there must not be a radical sign in the numerator. The third one is f of x equals x plus 3 divided by 2 plus 2x raised to 5/3 minus 3x. The third example is not a rational function because the denominator must not have an exponent, which is a fraction. So we have here an example. A Siomai vendor can wrap 4 dumplings every minute. If he wraps a total of 32 dumplings, how much time did he spend wrapping? Use the following to justify your answer. So we're going to use the table of values, the graph, and the last one is the equation. So we have here the solution. For A, we will complete the table using the given information provided in the problem. Since a vendor can wrap 4 dumplings per minute, we will add 4 dumplings for every minute until we will reach 32 dumplings. So we have here the table. So the first one is number of dumplings wrapped, and the second one is minutes. So if ever he wraps 4 dumplings, that is equivalent to 1 minute. If it's 8 dumplings, that is equivalent to 2 minutes. So every 2 minutes, he wrapped 8 dumplings. If it's 3 minutes, he wrapped 12. If it's 4 minutes, he wrapped 16 dumplings. If it's 5 minutes, he wrapped 20 dumplings. So on and so forth. Now let us plot the points on the Cartesian plane. So we have here the plotting on the right side. So for C, we can solve the problem by formulating a formula where we divide the total number of dumplings made by the number of dumplings per minute. So in symbols, so we have here the formula T, or the time in minutes, divided by D, total number of dumplings made, divided by N, the number of dumplings made per minute. We have here the important reminder So tell the students to use proper scaling and labeling. It is important that the graphical representations are neatly made, especially if not using a graphing paper. So if ever you are graphing, it must be labeled for the accurate plotting of points of ordered pairs. For our example 2, we have here represent the speed of a runner as a function of the time it takes to run 100 meters in the track. So we have here the solution. Let x represent the time it takes to run 100 meters. So we have here the equation. S of x equals 100 divided by x. So your x is the time it takes to run the 100 meters. Example 2, continuing the run time in the second example. Construct a table of values for the speed of a runner against different run time. So we have here the solution. Let x be the run time and b the speed of the runner in meter per second, where s of x equals 100 divided by x. So we have here the table. So your x is the run time and your s of x on the second one. So we have here, if your runtime is 10 seconds, your s of x is 10 because 100 divided by 10 will give you 10. If your runtime is 12, so 100 divided by 12 will give you 8.33. If your runtime is 14 seconds, that is 100 divided by 14. That will give you 7.14. If your runtime is 16 seconds, that is 100 divided by 16 will give you 6.25. If your runtime is 18, so 100 divided by 18 is 5.56. So note that the speed decreases as time increases. So as your time increases, the speed also decreases. So you can see that in the table. So we are now going to plot the points on the Cartesian plane. So we have here point A, point B, point C, point D, point E, and point F. So that is what you call our ordered pairs. So let us plot the points on the Cartesian plane. First, let us identify what are your x's there. So your x's are 10, 12, 14, 16, 18, and 20. And your y is 10, 8.33, 7.14, 6.25, 5.56, and 5. So after plotting the points, we have here the points on the Cartesian plane. And the second one is by connecting the points, we can see that they are not collinear but rather follows a smooth curve. So before we end this video lesson, always remember that the rational function is written in the form f of x equals p of x divided by q of x. It should follow the following conditions. First, both p of x and q of x are polynomial functions where it has no negative and fractional exponents. The second one is the denominator or q of x should not be equal to 0 because the answer is undefined. The third one is the denominator of all values of x where q of x must not be equal to 0. So that's all. Thank you for watching. See you again on my next video.